Hello again. This afternoon, we're going to derive the power of the test. Okay, power. Okay, of test. Let us assume that we have a one-sided test. Now, say the null hypothesis is that mu is less than or equal to mu 0, and the alternative is that mu is greater than mu 0. Right. So, as usual, we say that we reject the null hypothesis if the z-stat, okay, is greater than the z critical, right? Okay, so here we are assuming that the level of significance is alpha. Okay, the critical z would be the z of, since this is a one-sided test, we say z of 1 minus alpha. Okay, that's the critical, right? Or you just write it out as z of 1 minus alpha, like that. Okay, but okay, using this condition, right, we say that we reject the null hypothesis if z stat, which is x bar minus the mu 0 divided by the standard error. The standard error here is sigma all over square root of n is greater than z of 1 minus alpha over 2. Okay, so as you can see here, this corresponds to the condition where x bar is greater than z, that's just 1 minus alpha, z of 1 minus alpha times sigma all over square root of n plus mu 0. Okay, so this is where we're going to reject the hypothesis, meaning if we have the normal distribution here and we're going to plot your x bar. Okay, so when the null hypothesis is true, when HO is true, we have that mean is equal to mu 0. Okay, and so this one is in the mu 0. Okay, now we are going to reject the null hypothesis when x bar happens to be greater than this number here. Okay, so let's assume that this is letter A. Okay, yeah, so that's letter A. Okay, remember, say this is letter A, and remember that the area to the right would be alpha. Okay, right, that's just it. The area to the right is alpha. Okay, so now we say that we reject the null hypothesis when x bar is greater than or equal to A, or when x bar is greater than A. Now, under when the true mean is equal to mu 1, right? When the true mean is equal to mu 1, say, let us suppose mu 1 is this. Now, say this is mu 1. Okay, and so this corresponds to that normal distribution. Okay, when mu is equal to mu 1, we say that power is equal to 1 minus beta. Okay, but beta is equal to the probability that you do not reject HO. Okay, we do not reject HO. Okay, so we don't reject HO given that HO is false. Okay, this is to say that the probability that we do not reject HO, when x bar is less than A. Yeah, right, when x bar is less than A, we do not reject HO given that the mean is equal to mu 1, right? So we're saying here that the beta is the area. Okay, this is the area under the blue curve, no? To the left of A and under the blue curve, no? Okay, to the left of A. Okay, let me just put this here. So the area here, the beta here for you to see would be this. It would be this area, okay? Right? That's your beta. That is the probability that X bar is less than A. That is when you don't reject the null hypothesis, given that the mean is mu1 and not mu0. Right? So let's calculate this one. Here, okay, you have your beta is equal to the probability that X bar is less than A, but A is equal to this thing here now. Okay, let me just put here S less than A, given that mu is equal to mu1. Again, we're going to convert this into normal distribution. Probability that X bar is less than, okay, instead of X bar, we're going to make it Z. You know? Z is less than, you know, A minus mu1 divided by standard error, sigma over square root of n. Yeah. Okay, so this is the beta, the probability that your Z is less than this number here. Okay. So we're saying now that, okay, this is going to be the probability that, you know, Z is less than, okay, your A here, this is your A, Z of 1 minus alpha, okay, times sigma over square root of n plus mu0, okay, and then we subtract mu1 here, divided by sigma over square root of n. Right. So as you can see here, beta is equal to the probability that Z is less than, so sigma over square root of n will cancel out, so we say Z 1 minus alpha plus mu0 minus mu1 divided by sigma over square root of n. Yeah? Correct? Yes. Okay, or simply put, we just say that, you know, this is just the area to the left of, you know, this thing here, Z of 1 minus alpha plus mu0 minus mu1 divided by sigma over square root of n. Okay. Right, so that's your beta. So therefore, your power of the test would be 1 minus beta, 1 minus this. 1 of phi Z of 1 minus alpha plus mu0 minus mu1 divided by sigma over square root of n. Okay. So here, your power would be seen with this area here, right? This area under the blue curve to the right of A. Okay, that is your power, and so that's how we derive the power of the test. Okay, so visit me again and the mygraduatetutor.com. Thank you.